in, but then it's for whatever reason, it dropped its speed. And the Morakot is the one dropped most significant, but you can see that. But still, some are going up. It's very quick speed and leave the Taiwan. So there's a very big variabilities appear to be associated with the terrain in Taiwan. And then talking about this, the southwesterly flow. So this is just, we're still working on this. More careful analysis needs to be done. But anyway, this is just Morakot with all the southwesterly, and this is the shady this color region was showing the big water vapor flux, and with this is the microwave satellite. You can see the asymmetry of the convection, but with showing this with the Typhoon Jamie, you can also see this southwesterly and also this asymmetry in the convection. Kameji, similar things. Karosa, southwesterly, and also the asymmetry of convection. Haitang and Torachi. So this looks like it's all these are the high rank heavy precipitation type of. Looks like they are associated with a certain southwesterly surge and also asymmetry of the convections. And in Duli and Likima, similar things. And then in Taiwan, in the year 2001, we have all this Doppler radar network. So one thing at that time, at least I noticed, is that looks like all the strong typhoon nearby Taiwan saw the concentric airwall structures. So this is a Minduri southwesterly asymmetry, but then later on form the concentric airwall. And the Jamie, similar thing. Then form the concentric airwall. So if we say the concentric airwall formation is something important during the time of the typhoon or tropical cyclone, it's going through this to this. And this one is a radar, and this one the barotropic vorticity dynamics, barotropic calculation. So what we see here, this one, Likima will stay in the south part of the Kending Doppler radar for 36 hours, and actually. During that time, Central Weather Bureau, Uda Rong called me and asked me he wanted to show me something interesting, and indeed I thought it's quite interesting, seeing this huge blob of convection originally here, but then it's being wrapped around and form the concentric airwall. So I was just, based on that, I was hypothesized one possible mechanism would be something like a binary vortex inhalation. This is a stronger one, and this is a weaker vortices, and how it can wrap around and form the concentric eyewall. And in these processes, you can see the contraction of a secondary eyewall maximum. So this is all published in 2004 and 08. So this is pretty much based on this dynamics. And so here is we published in 2008. You can see the heat convection. Looks like if you hypothesize this is a huge of the weak vorticities, and then it's being wrapped around in 12 hours, showing the concentric. So, and in 08, Tui and Montgomery, they arguing about this, the beta skirt thing and Wishy. So the argument was pretty much saying that this skirt has a vorticity gradient, and once you have some vorticity pop up here, reverse the vorticity gradient, so the vortex loss speedway energy can accumulate in here, and maybe some convection or Wishy thing help pop up the secondary eye wall. So what I'm thinking, maybe just the mechanism here is not really fighting each other, because this one is axisymmetrized, form a circular shape, and while it's forming the circular shape, it's really helping the BSA mechanism, and while the convection surely can come in play. But in any way, looks like from all these things, to understand the concentric eyewall, you need to look at the detailed core structure. But also, if this is a mechanism, you also need to look at what's happening in the mesoscale process generating the vorticity in the TC environment. And maybe this TC environment or this vorticity things was related to the southwest research in the northwest pack. And we're looking more into this because we see many cases of such is the case, but we need careful examination. And then for this, just a mesoscale, as you heard people talk about with all this convection. So this is the, we cut and paste the radar images. So this shows 33 hours heavy rain. So it's really this the weak circulation and southwesterly surge and a very strong westerly coming in, and surely it's some conceptual maybe by backbuilding by Johnson, but still needs to be careful. But I just want to say, in the typhoon jamming, you see the similar things happen. So this mesoscale thing is not something that unique. I think it's happened many times. And Minduri also showed one like this. And I believe Benjo this morning showed other cases. So in Taiwan, actually, all the forecasters not only know that this is southwesterly, for a long time they know this so-called northeasterly monsoon surge. That is something when the typhoon was very far away in the Philippine Bazi Channel, then the forecaster aware that there's a very strong possibility that the northern part of Taipei had a heavy precipitation. So this is a Typhoon Linan case. So the whole idea was really pretty much a circulation. This meets with a northeasterly surge. So, and then in Huang Xiong's, their work in the GIL, they talk about this Morakot and this atoll. So this formed 6 days after this. But then I think it's also, this is from now and now, it's a mean JJA cometology. It's kind of similar. And then in Soviet, the president showing one storm after the others with a contraction of the scale and then form. So here is this is an old paper, old Chinese paper. It's quite interesting, back before the satellite era. This is a 700 millibar sounding, putting the easterly wind, and this is the date and month. So you can see the tropical cyclone form, or Taiwan form at the boundary of the east and west, which are this low frequency thing. So we hypothesize this is some of the wave accumulation. We published this in JS. It's really the nonlinear wave accumulation things. And also the monsoon flow is quite important to shape